Richard Feynman won a Nobel Prize for the most accurate theory in the history of science. Then he stood in front of a packed lecture hall and called it a dippy process, a shell game. His words, not mine. And that's the part nobody tells you. The most successful equations humans have ever written are held together by a mathematical trick even their own inventor thought was dodgy. So tonight, I want to show you what Feynman actually saw when he looked at modern physics, and why he quietly believed it's more broken than most people realise. G'day, welcome back to Curious Physics. If you've ever looked at a physics equation and felt like something was being hidden from you, you were right. Grab a cuppa, this one gets uncomfortable, in the best way. Let's start with the line Feynman made famous. He said, "I think I can safely say nobody understands quantum mechanics." Now sit with that for a second. This wasn't some random commentator on the internet. This was Richard Feynman, the bloke who rebuilt quantum theory from scratch, who drew the little diagrams every particle physicist still uses today. If anyone understood it, it should have been him. And he straight up said he didn't. So what was he on about? Here's the thing that broke his brain. Imagine you're standing at the edge of the Yarra and you start flicking pebbles into the water. The ripples spread out in circles. Flick 2 pebbles at once and the ripples meet in the middle. Some waves add up, some cancel out. That's wave behaviour. Normal, predictable. Now swap the pebbles for electrons. Fire them one at a time through 2 tiny slits at a detector. Not in waves, one electron, then another, then another. What do you reckon should happen? You'd expect 2 neat stripes on the detector, right? 2 slits, 2 stripes. Simple. That's not what happens. You get the ripple pattern. The same interference you'd see with waves, except you're firing single electrons, one at a time. Each electron somehow interferes with itself, as if it went through both slits at once. And here's the kicker. The moment you peak, the moment you set up a detector to watch which slit the electron actually went through, the pattern vanishes. The electron suddenly acts like a boring little bullet. 2 stripes. Done. Just by looking, you change the answer. Feynman's point was never that this is hard maths. The maths works beautifully. His point was that nobody, not him, not Einstein, not the smartest physicist you can name, can tell you why nature behaves like this. We've got the recipe, we just don't have the first clue why the recipe works. And that's crack number 1. Now here's where it gets really spicy. Feynman's biggest achievement was a theory called quantum electrodynamics, QED for short. It's the theory that describes how light and matter talk to each other. Electrons, photons, all the good stuff. And QED is ridiculous. It's the most precisely tested theory in human history. We're talking predictions that match experiment to about 1 part in a trillion. That's like measuring the distance from Perth to Brisbane and getting it right to within a human hair. Sounds brilliant, yeah? It is, except for one tiny detail. When Feynman and his mates first wrote down the equations, the answers came out as infinity. Not a big number, not a messy number, infinity. The theory said an electron has infinite mass, infinite charge, infinite everything, which obviously is cooked. You can't have an infinite mass electron. The universe would have collapsed 10 minutes after the Big Bang. So what did they do? They cheated. Politely, but they cheated. They invented a trick called renormalisation. The basic idea, you take the infinities in your equation and you subtract them away using other infinities. You manually cancel the nonsense. And somehow, nobody really knows why, when you do it carefully, what's left over matches reality perfectly. Feynman himself hated this. In his book on QED, he literally wrote that the shell game physicists play to get rid of the infinities is a dippy process. He said no matter how clever the word renormalisation sounds, It doesn't change the fact that you're basically fudging the books and hoping nature doesn't notice. And here's the bit that should make the hairs on the back of your neck stand up. Nature doesn't notice. The fudge works every single time to 12 decimal places. Think about what that means. The most accurate theory we've ever written only works if we illegally cancel infinities we don't understand. Feynman compared it to an accountant who keeps his books balanced by quietly setting fire to the bits he can't explain. And yet the accountant always gets the tax return right. That's not a theory. That's witchcraft with a PhD. And this was the guy who built it. If Feynman didn't trust his own equations, maybe we shouldn't either. Now, at this point, you might be thinking, all right, physics is a bit weird around the edges, but surely the big picture is sorted. Newton, gravity, atoms, all that? Yeah, nah. That's where it gets worse. Because quantum mechanics, the weird, infinity fudging, observer-sensitive mess we just talked about, only describes the tiny stuff. Atoms, electrons, particles you can't see. The moment you zoom out to planets, galaxies, black holes, it hands you over to a completely different theory, Einstein's general relativity. And these two theories, they hate each other. They both work, they both make predictions that match reality, but if you try to mash them together into one theory that explains everything, from the smallest electron to the biggest galaxy, the maths literally breaks. You get more infinities. And this time, no fudge makes them go away. This isn't a gap. This is a full-blown civil war at the heart of modern physics. Here's a way to picture it. Imagine you've got two mates sharing a house in Melbourne. One of them, let's call him Quantum, works night shift and only cares about what happens on the microscopic scale. The other, Relativity, works days and only cares about big, heavy things, gravity, planets, the shape of space-time itself. Individually, both of them are legends at their job. Quantum predicts how your phone screen lights up. Relativity is why the GPS in your Uber knows you're driving down Chapel Street and not Swanston. But try to get them in the same room? Pure mayhem. Black holes are where the fight really kicks off. A black hole is heavy enough that gravity dominates. That's relativity's turf. But at its centre, everything gets squished down to a point smaller than an atom, which is quantum's turf. And the equations just stop working. They don't give you a sensible answer. They give you gibberish. Feynman saw this coming decades ago. He tried to quantize gravity in the 1960s to force the two theories to get along. He couldn't. Nobody has. Every attempt since, string theory, loop quantum gravity, you name it, has either failed to make a testable prediction or tied itself in knots of math so abstract that some physicists joke it's basically philosophy with symbols. And this isn't a small problem. This is the problem. If you can't unite gravity and quantum mechanics, you don't have a theory of the universe. You've got two halves of a broken map. And now for the bit that really keeps me up at night. All of the physics we just talked about, quantum mechanics, relativity, the standard model, the whole circus, describes roughly 5% of the universe. 5. The other 95% is made of stuff we've named but don't understand. Dark matter, dark energy. We call it dark because we can't see it, can't touch it, can't make it in a lab. All we know is the galaxies spin wrong without it, and the universe is expanding faster than any known force can explain. So let me get this straight. We've got a quantum theory that needs illegal maths to work. We've got a gravity theory that refuses to play nice with it. And together, the two theories we're so proud of describe $20 out of every $400 the universe actually has. On top of that, there are about 20 numbers in physics that we just measured and plugged in. The mass of the electron, the strength of gravity, the speed of light. Nobody knows why any of these numbers are what they are. Shift them by a fraction of a percent and the universe either collapses or never forms stars at all. Yet we can't derive them. We just copy them off reality's answer sheet. Feynman called these the magic numbers. He said any physicist who claims to understand them is either lying or hasn't thought about it hard enough. So was Feynman being dramatic? Was this just the musings of a grumpy genius? No. And here's the part I want you to really sit with. Feynman wasn't saying physics is wrong. He was saying physics is unfinished. There's a difference. Newton wasn't wrong, he was incomplete. Einstein came along and showed where Newton's gaps were. Then Einstein became incomplete. Quantum mechanics showed where his gaps were. And now we're standing on the other side of that story, and Feynman is pointing at the next wall. The wall nobody has climbed yet. His real message was this: the biggest lie in science isn't a bad equation. It's the pretense that we've figured it all out. The moment physics stops being honest about what it doesn't know, it stops being physics. It becomes religion with fancier hats. That's why Feynman still matters. Not because he had the answers, because he refused to pretend. Physics isn't broken because it's failing. It's broken because reality keeps being weirder than the tools we invent to catch it. And that right there, is the most exciting sentence in science. If that cooked your brain even a little, do me a favour. Hit the like button, smash subscribe, and drop a comment telling me which bit blew you away the most. Was it the infinities, the observer effect, the 95% of missing universe? Next video, we're going somewhere proper mental. We're falling into a black hole together, and I'll show you exactly what physics says happens to you on the way down. See you there.